So we're trying to find the volume of a solid uh, from the revolution of a plane region. Okay, so look at the middle graph on this page. You see a blue region under curve, and you rotate this region by the x-axis, and you want to find the volume of the solid, like the blue solid. So what we do is we cut this plane region into rectangles, and then when you rotate each rectangle, you get a disk. Now, if you cut this plane region into many rectangles, after rotation about this region about the x-axis, you're going to get a bunch of disks, as you see in the last graph on this page. Then you use the volume, or use that those disks to approximate the actual blue solid. So the yellow disks approximate the blue solid. So you just add all the volumes for the disks and to get the approximate value of the solid in blue. So that's the disk method. And you can easily calculate the volume of the disk, and then take the limit. In order to get the precise value of the actual blue solid, you need to take the limit with the cutting into infinitely many disks, so that every single disk will be extremely thin. Once you complete the limit process, then the approximation is approaching the actual precise value of the volume. Okay, so then the sum of the volumes of disks becomes the integration. Become an integration, just like we did before when we cut the rectangles to find the area on the curve. It becomes integral, and the integral has the formula like this. If you rotate about the x-axis, the blue region, okay, so we got the curve on the top, and then below it is the blue region you rotate, and then the volume of the solid from the rotation of the blue region under the curve of Rx. Okay, so Rx is the function, the curve, okay, the top curve. And then the volume of the solid will be pi times the integral from a to b. Okay, so this x starts from a, ends at b for the blue region, as you can see from the graph. So integrate from a to b of r squared, where r is the black curve on the top of the blue region, the function. Okay, so just keep in mind that's how you do it. So that's the case when you rotate about the x-axis. When you rotate about the y-axis of the blue region, then you just integrate over y instead of x. I'm sorry. So in this example, we need to find the volume of the solid by rotating the shaded area in this graph on the right, and this shaded area is bounded by the function of f equal to square root of sine x. So the top blue curve is square root of sine x. That's the function. And from 0 to pi, okay. So that's the whole region. We rotate this region by the x-axis and find the volume of the solid. So what you do, just use the formula. Okay, as I said, the formula is just v equals pi times the integral of from a to b of r squared, where r is the top function, the top curve function, which is the square root of x. So in the disk method, you just plug in the top function in the formula and integrate. Okay. So then when you square root of sine x, you're going to get the sine x. So we get a pi times the integral from 0 to pi sine x. The integral is from 0 to pi. So x is from 0 to pi. In this blue region, in this yellow region, all right? So if you integrate sine x, you get the negative cosine x. And then you just plug in 0 on the pi and subtract. So we got the pi times negative cosine pi minus negative cosine 0. Cosine pi is negative 1, so if you take the negative cosine pi, that would be positive 1. And the cosine 0 is 1, so you get negative cosine 0 to be negative 1. So at the end, you get the pi times 1 minus negative 1. So that gives you 2 pi. All right? Any questions? So we did that. How did the sine x determine the cosine? You integrate the sine x. Okay. You remember you find the antiderivative sine x. That is the negative cosine x. That's how you integrate, right? So find the antiderivative. Any other questions? So that's the disk method. Now there's a variation of this disk method. That's called the washer method. The washer method is actually a variation of the disk method. And regard that as the same as the disk method. The difference here is we have two curves. If you look at the plane region, the blue plane region in the middle, the blue region is bounded by two curves, one on the top and one at the bottom, right? So we call these two curves big Rx and small Rx. Okay, those are the two functions, two equations, okay, if you want. And then we rotate the region bounded by these two curves by the x-axis. Then you're going to get a solid like this on the right. You get a hole in the middle, okay? And we define the volume of this hole. And if you use the disk method in this problem, then what you do is just subtract two volumes, okay? The volume from the top curve by disk method and the volume from the lower curve by using disk method also. So this is actually same as disk method. The only difference is you have two curves now, but you plug in almost the same formula, okay? So again, you just cut this plane region into many regular angles in yellow in the graph. So you rotate each regular angle, you're going to get the washer instead of disk because now you get a hole inside. All right. So if you look at the left-hand side on the top, you got the regular angle, which is the same as the regular angle in the middle graph, the yellow regular angle. It's just enlarged. Okay, and you rotate this regular angle, you're going to get a shell at the bottom. And then you just easily calculate the volume of the shell by taking the difference of the big disk and the volume of the hole, which is also a small disk. So if you call the radius of rotation of the big disk big R and the radius of the small disk, which is the whole small r, then you can take the difference of the two volumes to get the formula. Okay, so you can see the formula is very similar. So consider a region bounded by outer radius, big Rx. Okay, in the middle you can see the top curve, and the inner radius, small Rx, the bottom curve. And then, these are the two functions, two curves on the top and at the bottom. Okay, remember that. The volume of the solid of revolution by x-axis is given by the formula of v equals the integral from a to b. Okay, so ab is just the two ends on the x-axis of the blue region to rotate. So the integral from a to b of pi times big R squared minus R squared. Okay, so previously in the disk method, we only have the big R squared. Now you have a hole in the middle, so you subtract the R squared. Now that's the only difference. Then everything else is the same. Then you integrate. Similarly, if the evolution or rotation is by the y-axis, then you just change the integral from x to y. All right. So let's just do one example to use the Warship method. Okay. So we need to find the volume of the solid formed by revolving the region bounded by the graphs y equal to square root x and y equal to x squared above the x-axis. Okay. So we got two curves here. If you draw the graph of this bounded region, okay, so what happens? All right. So we got two curves in here. On the top curve is the curve of big R equals square root x. Okay, if you draw the two curves, you're gonna get a square root of x on the top, and the bottom curve is x squared. Okay. So those are two curves, and the region, enclosed or bounded by those two curves, you rotate this region by the x-axis, and you want to find the volume. So what you do, just use the formula for the Warship method. So v equals the integral from a to b. In this case, it will be 0 to 1. So how do you find this 0 and 1? Okay, how do you know two endpoints or 0 and 1? You actually need to solve the equations first. So let's just go back to the original problem and find this two endpoints 0 and 1. Okay, so we need to find the two endpoints of region A and B. There is then the two curves. You can see from the graph. The two endpoints are the intersections of those two curves. Do is just the two functions equal and solve it. Okay, so we get the square root of x equal to square. Those are the curves. Remember in our problem. You solve it. You take the square of the equation. So on the left, you get the x squared, which is x itself, and by the x to the 4th. So you want to take the square root, and that take square root. You take the square. Okay, then you do not cancel x. Okay, please don't do that. Always not do that. To solve this equation, you put all the terms on one side. So subtract x to the 4th to the left. So you get x minus to the x 4th equal to 0. And then you factor it. Okay, that's the way to solve an equation. Always factor. So then you factor x from the left side. You get 1 minus x cubed. Remember, when you factor x from x, you get 1. And then from x to the 4th, you get x cubed. Now, you set each factor equal to 0. So x equal to 0 or 1 minus x cubed equal to 0. Solve this equation. I got the problem with my video today a lot. Sorry about it. So you got two solutions. From the first equation, you get equal to 0. Always we have it. from the equation 1 minus x cubed equal to 0, obviously you get x equal to 1. So that means the two endpoints are x equal to 0 and x equal to 1, and a equal to 0, b equal to 1. All right, so those are the intersections of the two curves. So you can see it from the graph. X equal to 0, that's the origin, and y equal to 1. I mean, x equal to 1, that's the right-hand side endpoint. So these are the two values for a and b. You integrate from 0 to 1 on the x-axis. So then we just go back to the formula for the Washer method. Integrate pi times big R squared minus small r squared from a to b, so from 0 to 1. But what is the big R? That's the top curve. The small r is the lower curve. Okay, just keep in mind those, then you'll be good. Okay, in the Washer method, you have two curves. You always subtract the square of the top curve and the square of the lower curve. While in the disk method, you don't have the lower curve, so you just take the square of the top curve. All right. So now we got square root of x on the top and the x squared at the bottom. So we square both. So if we square root of x, you get the x itself, and the square x squared, you get x to the fourth. And then you integrate, x minus x to the fourth. You get x squared over 2 minus x 5 to the 5 using the power rule, remember? And then you plug in 1 is 0 for x and subtract. So we get a pi times 1 squared over 2 minus 1 to the 5 over 5 minus pi times 0 squared over 2 minus 0 to the 5 over 5. So plug in 1 and 0 for x and subtract. Okay, so obviously you get everything 0 in the second part. In the first part, the 1 squared, 1 to the 5, they're all 1. So you get the pi times 1/2 minus 1 over 5. And then you just subtract these two fractions by finding the least count denominator, which is 10 in this case. 2 times 5 is 10. So you rewrite 1/2 as 5 over 10 and the 1/5 over as 2 over 10. So then you subtract 5 over 10 and the 2 over 10, you get the 3 over 10. You have to have the same denominator to subtract the numerator. Okay, so at the end, the answer will be 3 over 10 times pi. Any questions? So that's the shell method. Okay, so you can see, Washer method. You can see the disk method or the Washer method is very simple. Okay, you got the top curve and the bottom curve. What you do is just plug in the top curve as the big R and lower curve in the small r in the formula and integrate. If you don't have the lower curve, then it becomes a disk method. Then you have the big R, plug in big R and integrate the formula, and you get the answer. Any questions at this point for the disk method and the Washer method? Does that make any sense? I think it is relatively simple for the disk method or Washer method. And the idea, the original idea is cut the whole region, into regular angles like this. Okay, so you can see in the disk method or Washer method, the way you cut the regular angle is perpendicular to the rotation axis. You can see we rotate the blue region by x-axis. So we cut the region by regular angles perpendicular to it. So at the end, you're going to get a disk, a washer, perpendicular to the rotation axis. And you can also see the same kind of thing in the first page. When there's no lower curve or bottom curve, then again you cut the regular angle perpendicular to the rotation axis. So we rotation about the x-axis again in this graph, and the regular angle is just perpendicular to it. And if you rotate this the regular angle, you get a disk. So the disk is perpendicular to the rotation axis. Is it good? Does it make any sense to you?
Yes, it does.
Yeah, just tell me if you got any questions anytime, because I want to make sure everybody's comfortable with that, understand everything, how to apply these formulas in the problems, because you're going to do a lot of homework and you're going to do quizzes. So you do need to know how to work on the problem. Okay. And the disk method or the washer method is basically look at the top curve and the bottom curve. That is the big R and the small r. Plug into the formula and integrate. That's it. In the disk method, when you do not have the bottom curve, you just plug in the top curve, the top function, okay, into the formula and integrate that, and that's it. Nothing really complicated in here. But make sure, when you have the formula for the big R square, that is actually the function of the top curve. In the case of the washer method, you got two curves, one on the top, one at the bottom. So you plug in the top curve, top function, to big R, on the bottom curve, the bottom function, to the small r, and into the formula, and then integrate it, and that's it. As we did in the example. Okay, so that's the whole idea about this method.